Yes, hello, ladies and gentlemen, how are you? I think that you are okay. Then, the lesson of the day is Unit 2, called electronic configuration. And before going to deal with this question, let us think on the following question. Answer question in the next slide. This question should be answered after learning this unit. I would like to call every student to be attention, to have a kind of attention, because at the end we do a pop quiz. Then, before we're going to start with this unit, let us put some morale. Yes, let us continue because the time is money. Question 1. Define atomic orbit. Explain states 3 main laws of electronic configuration. States 3 postulation of Bohr atomic model. State 2 achievement of Bohr. Explain 4 limitation of Bohr atomic model. This is the question. Question 6. Explain 4 quantum number by Schrödinger equation. Distinguish excited from the excited, or emission from absorption of spectral line. Find group and period using SPD notation. For chromium, if atomic number is this, aluminum and calcium, and this is the question I have to answer after running this unity. 2. Then unit 1. Unit 2, we are going to see electronic configurations. Then, in this unit, we are going to see how to find the electronic configuration of a given element and how to find a group and period. Example for S block, we have example lithium. Lithium we have in S block. Group is this one and period is this. For P block, we will, for example, this is a P block. We will have to find a period. The period is 2 because it is maximum energy levels. A period is 2. What about the group? A group, we are going to take this 4 plus 2, it is equal to 6 plus 10, it is equal 16. This is a group. For D block, example, we have copper, atomic number is 29. Then this is an noble gas notation. We have a 3D10, 4S1. Then a period is a 4, whereas group we will take this 2. This one add 10. It means that we have this group 11. Ahangaha ureba iyo ukoze electronic configuration muri S block, iyo ureba umubare w'inyuma kuri S niwe group. Noneho period ni umubare wasorejeho munini, energy levels nini cyane. Kuri P block formula ni ufata electron zo kuri S n'izo kuri P ukaziteranya ukongeraho 10 ni formula. Example, oxygen, it has 8 atomic number. Then you have 1s, 2s, and 2p4. Then you are going to find a period. The period is a 2. What about the group? We are going to take this 4 plus 2. It is equal to 6 plus 10. It is equal to 16. This is how to find a group. Kuri D block ufata electron zo kuri S ugateranya electron zo kuri D. Example ahangaha dufite copper. Ahangaha ushobora gukoresha orbital yes, amine noble gas notation ukafita iyi ni argon ifite 18 electron plus 3d 10 plus 4s1. How to find a period? Period ni umubare munini cyane. Hano dufite 3, hano dufite 4. Uyu nguyu niwe maximum energy levels iraba 4, niyo period. Group urafata ino rimwe uteranyeho ino 10. This is how to find a group is by using SPD, yes, notation. Here there is a formula by using electronic configuration SPD notation. Here we have 1s2. Ahangaha izi ntuza iyi niyo ukwiye kwifashisha, ukwiye kubuzi kugira ngo ubashe gukora electronic configuration yayo yose. Hano tuba dufite 1s2 2s2. Iyo tuvuye ku 1s2 tujya kuri 2s2, twava kuri 2s2 tukajya kuri 2p, twava kuri 2p tukajya kuri free, twava kuri free tukajya kuri 3d, tukava kuri 3d tukajya kuri 4, tukajya kuri 4 tukajya kuri 5, twava kuri 5 tugahita tuza hano inyuma tugatangira kuri 4d, twava kuri 4d tukajya kuri 5p, twava kuri 5p tukajya kuri 5 yes 5s is it p? Yes, I think that ni s6 ni s. Twava kuri s tukahita tujya kuri 4f, twava kuri 4f tukajya kuri 5d, tukava mbega uko ahangaha nabitondetse, uko nabyanditse ku murongo niko ugenda wabanze 1s ujya kuri 2s ujya kuri 2p, 3s 3p, uvuye kuri 3p urahita ujya kuri 4s, nuva kuri 4s urahita kuri 3d, nuva kuri 3d urajya kuri 4p. Urabona ko 3d ije hano hagati ya 4s na 3p. Ni ngutyo bitondeka warangiza ukabara bitewe na ntuza baguhaye electronic configuration bitewe na element baguhaye. Yes, niba ari ya 10 ndabara hano dufite ebyiri, hano dufite ebyiri, zirahita zibenye gushyiraho esheshatu zahita ziba 10. Urugero nka none ya 10 ubwo ni ngutyo. Ubwo niba ari nka ya 12, yes, nka magnesium ubwo nuko garukira hangaha. Niba ari ya 10 wenda n8 argon ubwo ndagarukira hangaha. Yes, nuko nguko. Yes, ukwiye kwivumenya electronic configuration, yes, in order to do every element that are given. Yes. Also here we have, this is the example how to find a group and period by using SPD notation. We have iron with 26, we have chromium 24. This is the answer for this chromium. We have a 3d5 4s. Group is a period is a 4. Group is we are going to take, because it is a d block, this chromium is in d block, we take this 5 plus 1, it is equal 6. Group is a 6, period is a 4. Yes, this is examples. This is examples. Try to do in your exercises book. Yes, this is manganese 25. Try to do electronic configuration and find the group and period. This is also aluminium, also calcium, also manganese 2 plus. Ahangaha yatakaje ebyiri. Urugero nkanga magnesium. Manganese ntabwo ari magnesium. Manganese ifite 25. Ukoresheje noble gas notation ahangaha ufite argon. Ubwo biraba 3d5 4s s1. Ahangaha ni itakaza ebyiri, iratakaza izingizi zahangaha ntabwo irataka. Yes, ubwo ahangaha niko biganga yatakaje ebyiri. Aha tukiri kwishakira tuyishakira group na period. Ahangaha iraba iri muri period ya kangahe ya 4. Ubwo group urafata kano kabiri utanyo gatanu bahita biba 7. Usanga iri muri group ya 7 period ya 4. Nuko nguko bashaka electronic group na period. Then sorry for using Kinyarwanda. Most of the time I try to use English, but sorry for that. Here also we have also other 3 main laws of electronic configuration or principle of electronic configuration. First one is half buff or breathing up. What state that when you are filling electron orbitals, example, if ahanga yigerageje gushyira electron ku ma orbitals, uhera kuri orbital ya mbere ugira ukajya kuyikurikiye, uhera kuri ifite lower energy levels. For instance, hano here we have 1s2 and 2s2. Ahangaha iyi ni iri kuri lower energy levels, ahangaha iri kuri high energy levels. Turatangira kwingi turi kuzuza ama electron muri orbitals. Ahangaha niturangiza kuzuza kuri lower energy turahita tujya kuri high energy levels. This is how half-buff says, state that filling electron in orbitals, we start from lower to high energy levels. For Hand's rule, we start for the same energy levels. Example, ahangaha ufite orbitals ufite same energy levels. For urugero ahangaha kuri p block, kuri p orbitals dufite px na py na pz. Ahangaha ko zifite energy level zingana, umanza spin up, umanza electron ziri spin up before yo gukora spin down. This is how Hand's rule says. For Pauli exclusion avuga ko nta electron zirenze kwe kurenga ebyiri muri orbitals imwe. Ahangaha no more than 2 electron is allowed in one orbitals. Ahangaha nimba ari eshatu ntabwo byemewe, electron zirenze ebyiri muri imwe ntabwo yabyemewe. Umanza muri orbitals imwe ushyiramo electron ebyiri, warangiza ugahita ujya mu zikurikiyeho kuza ukurikije izikurikiyeho. Example exercises differentiate using example for calcium orbital representation, expanded notation and noble gas notation. Ahangaha urakoresha orbitals nk'ingi, nujya kuri expanded urakoresha sp1 s2 2s2 ngutyo ukoresha union expanded notation. Kuri noble gas notation naho urayifashisha. Yes, in your exercise book, try to do it. Yes, I think that it is easy. Yes, it is easier. Here we have postulation of Bohr. Bohr explains stability of a stationary orbit. In a stationary orbit, electron cannot gain. Yes, it is where electron can rotate around the nucleus in a fixed position without emission of radiate energy. Ahangaha kuri stationary phase or ground state, electron ibiri ntabwo iba yigeze itakaza energy cyangwa gaining. Also explain atom can't release energy in stationary phase, stationary state. Also, this is the postulation of Bohr. We have a 1, we have a 2, we have a 3. Also explain transition energy. In transition energy, you deal with excited and the excited state. Here excited, when electron move from lower energy, first is we have this one. We have a lower energy. Here we have ahangaha electron kuri n1 energy level ya mbere, hano ikaba iri kuri energy level ya kangahe ya kabiri. None electron niva kuri energy level ya mbere ijya ku ya kabiri yabaye excited, mbega yagaininze energy. Yes, excited. None niva kuri energy level iyi ngiyi turayita kari higher energy levels, higher energy level. None ahangaha ni kuri lower energy level or on ground state. When electron move from higher to lower energy level, it is the excited. It is the excited. Ahangaha yavuye kuri energy yo hejuru ijya kuri energy yo hasi, hano yatakaje energy. Ahangaha yagaininze energy iri kuva kuri lower energy ijya kuri excited state cyangwa kuri higher energy levels. Here we have excited state. It is absolution. It is when electron move from lower to higher energy levels. I try to explain it from higher energy levels. Example, we have this, we have orbitals, we have this. Let us call this is N1. This is N1. This is N2. This is the N2. When electron move from N1, when electron move from N1 to N2, like this is excited. When it is moved from N2 to N1, it is de-excited. This is how electron is excited or de-excited. Here Bohr explains transition and explains stationary phase and explains atom can't release energy in stationary phase. This is the postulation of Bohr. Also, you have this formula. This is stand by n energy levels. This black constant. This is frequency. This is also explain orbit. Orbit is a fixed position where electrons revolve around the nucleus. This is the postulation of Bohr. We have a 3 postulation. Achievement of Bohr. Bohr tried to explain the atom is stable when electron is moving in its orbit. Ahangaha electron yiri kugenda, ahangaha iri kugenda kuri orbit ya mbere, iyi ni orbit ya kabiri, ahangaha ni orbit ya gatatu. Ahangaha iyi electron iri kugenda kuri orbit ya mbere nta hantu yahurira n'ingi iri kugenda kuri orbit ya kabiri, nta hantu yahurira n'ingi iri kugenda kuri orbit ya gatatu, keretse iba excited cyangwa ikaba de-excited, niho byahura. Ahangaha yavuze ko electron igenda kuri buri orbit, ariyo bita stability of atom. Yasobanuye stability of atom aho electron iri kugenda it's on orbit. Also the second one, it is a production of emission and production of absorption. Iyi emission ibaho ryari igihe electron yavuye kuri higher energy levels ijya kuri lower energy levels. Here noneho igihe yabaye excited, absorption ni igihe yavuye kuri higher energy kuri lower energy levels kuri ground state ijya kuri higher energy levels, niho iba excited. I think that you understand this achievement of Bohr. When electron move from here to here, it is excited or the same as absorption. Excited ni kimwe na absorption. None the excited ni kimwe na emission, loss of energy. When electron move from here to here, this is achievement of Bohr. I think that you understand. If you have a question, ask your neighbor. If your neighbor fail, come read the book. If you don't understand the book, yes, come to, yes, ask me, ask our teacher. I am here as a facilitator, not a teacher. Yes. So we have a limitation. Ahangaha Bohr yaje guhura n'imbogamizi ya mbere, ntago failure to explain, ntago origin of, hano ntago yashoboye gusobanura igihe electron ifite ahantu za spectral line menshi cyane. Hano byaramuyobeye. Hano yadirinze ku electron ifite no za electron makeya cyane. Urugero nka hydrogen, nka lithium, nka beryllium. Ahangaha ikindi failure to explain a circular orbit in which electron revolve are planned. Ahangaha yagerageje baramubajije ati yes, kubera iki electron yiri kugenda nyine yiri kumuvinga, yagakwiye kumuvinga kuri sako, yagakwiye kumuvinga hazi sako. Yes, ariko hano yavuga ko electron imuvinga muri 3 dimension. 3 dimension ni like this, 3 dimension. Electron yo aho kugira ngo igende kuri sako igenda muri 3 dimension. Baramubwiye ngo waje hano yafirinze kubisobanura. Yes, nayo n'ugutsindwa rero nuko nguko cyubasha kujya wemera. Ahangaha nawe yaremeye kandi yagerageje gusobanura ibintu byinshi. Ahangaha icya gatatu, fail to account Zeeman and Stark effect. Hano here Zeeman is a person and Stark is a person. Ahangaha bagerageje kwifashisha a magnetic field na electric field. Here Zeeman he used the magnetic field, here Stark used electric field. Ahangaha bose bagerageje kubona resulta zimwe, aho babonye spectral line gari fina and closed kandi bifashishije magnetic field. Magnetic field bifite yes, ifite north and south. Yes, north and south. But here kuri for electric field you have positive and negative, but the results are the same. Here they found thin and closed the spectral line. These spectral line zabaga zegeranye. Ifashishije magnetic Zeeman no Stark ifashishije electric, the results ziba zimwe. For more information, yes, look at here. This is for Zeeman. He used the magnetic field, but this is for Stark. He used electric field, but the results are the same. Ahangaha yifashishije electric field abona as spectral line ziri fina, izindi spectral line ziri fina and closed. Ahangaha naho yifashishije magnetic abona spectral lines ziri fina and closed. Abona ko he failed to explain those what caused it to be the same, even if the magnetic field are different. Yes. The fourth one, Bohr was in contradiction with Heisenberg and scientific principle. Uyu nguyu Bohr na Heisenberg banga bari mbega ibyo umwe yemezaga undi yarabihakanaga, ntabwo mbega babyumvaga kimwe. Urugero hano Bohr yavugaga ko byoroshye kudetermininga nimba electron iri kumuvinga kuri orbit. Urugero hano electron iri kumuvinga kuri orbit ya mbere n'indi iri kumuvinga, ahangaha biroroshye ko wamenya position na velocity, niko yavugaga. Ariko uyu nguyu we Heisenberg yavuga ko bigoye kudetermininga position na velocity of a small moving body. This is the full limitation of Bohr. Here also here light, ahanga iyo light iri kugenda igenda mu buryo bwa wave. Hano mu buryo bwa wave like this. You are physician. Wave ahanga urabona iyi ngiyi ko wave ari ntoya, none hari igihe wave ishoye kugenda. Wave urabona ahanga wave ni nini, hano wave length urabona ko yes, wave length urabona ko iri short. Ahanga wave length yari ntoya, frequency yahanga yes iba low. Ahanga none ko iyi ngiyi wave length yiri short, hano wave length yiri short, frequency here should be high. Yes, light as wave. Light with longer wavelength has a lower frequency. Light with longer wavelength has a lower frequency, whereas light with short wavelength, example here, has a high frequency. This is how the frequency is. Yes, hano bashobora kuguhereza nk'urugero bakakuba nimba wavelength ari ntoya, frequency, what about frequency? Nimba wavelength ari nini, what about frequency? Nuko nguko try to explain clearly. This is the example. This is examples. Yeah, this is the wavelength from here. This is the wavelength. This is a short wavelength, but from here to here. Also, this is a wavelength. Here is a short. Here is a long. Here we are going to see orbitals and quantum number. Here, electron in orbit should have a 4 quantum number. First one is energy level. The second one is a shape. The third one, third is orientation. Also, the last one is spine direction. This is the quantum number. Orientation and spine. Hano muri spine tuba tugifite spine up tukagira na spine down. Hano electro ikwiye kugira spine down na spine up. Urugero hano, if this is the S block, the S orbitals, this is the spine up, this is the spine down. Yes, for shape we have S shape, we have a P shape, P orbital, we have a D, and also we have F. Yes, here for energy levels we have energy 1, 2, this is free. This is press 1, 2, 3, 4. This is the quantum number. Electron 4 quantum number. Electron in atom should have this 4 quantum number. We are going to go in detail. One principal quantum number 1. It is a quantum number. Principal quantum number. It is symbolized by N. It indicates energy levels. We have K, L, N, M, N. Kalimanopok, you know, this is the energy levels. Also, angular momentum symbolized by L. Yes, symbolized by L. If example, or azimuth or second quantum number indicate the shape. In a shape we have S, we have S shape, we have a P, we have a D, and we have F. You know, in S, the shape is like this. In P, the shape is like this. In P, the shape is like this. Shape is like this. Shape is like this. For D, the shape is like this. This is the shape. Yes. For F, it is complicated. Here this shape, we have S shape, we have S orbital, L is equal 0. When L is equal 0, L is the angular momentum is equal to 0. Here we have S shape. S shape, the structure is like this sphere. When L is equal to 1, this is a P block. What about orientation? Here no orientation, but here we have a 3 orientation. You have this. We have this one. 3 orientation. We have a 3 orientation. If it is L is equal to 2, yes, we will have D block. We have a 5. We have a 5 orientation. Here, hano tuba dufite box eshanu, you know, kuri D block. Ubwo kuri F block dufite noza 7. Ubwo muri F hano L is, when L is equal 3, here we have F block. Hano kuri F block tuba dufite box zinga 7. Yes, hano tuba ubwo ni 7 orientation. This number is explained. Hano na orientation ibiri sphere S. Yes, if it is sphere. But here I think that this is the examples I try to do it. Also, the order of energy level. F has greater energy level than D block, than F block, than P block, and than S orbital. So is S block, yes, S block, no problem, or orbitals. This is the principal quantum numbers. Electron in atom should have a 4 quantum number by Schrödinger equation. Also, the magnetic quantum number, the fourth one, the third one is magnetic quantum number, symbolized by ML. If ML, this indicates orientation. This is the magnetic quantum number. For instance, if L is equal 1, yes, ML, magnetic quantum number will start with minus 1, 0, 1. If L is equal to ML, magnetic quantum number is equal to minus 1, minus 2 minus 1, 0, 1, 2. This is how ML is. Then what about spine direction? Spine direction, in our example we have a 1s. For instance, we have 1s2. In here we have a spine up. This is the spine up and spine down. This is spine down is minus 1 over 2. Whereas spine up it is plus 1 over 2. This is the spine quantum number is spine direction. Here we know this is the anti-clockwise, this is a clockwise. This is spine up clockwise, whereas spine down is anti-clockwise. This is anti-clockwise, whereas this is a clockwise. Here those are about the quantum numbers for n for a given electron in atom. Then what about spectral line? Spectral line we have Riemann series, Baumann series, Paschen, bracket, and Fund. We have 1, 2, 3, 4, 5. We have 5 energy levels. Here we have example. First we have N1. Here we have N2. Ahangaha ugiye kubaka zino ntuza no spectral lines ugerageza yes umurongo wa mbere ni energy level 1, uwa kabiri ni energy level 2, uwa gatatu ni energy level ya gatatu. Then hano kugira ngo umenye ukuntu hano dufite bano dufite Riemann series, dufite Baumann series, dufite Paschen and bracket and na Fund. Here we have this Riemann is UV, but for here Baumann you have a visible light. Here also this remaining is infrared rays. This is infrared rays. Then to breathe this spectral line, we start from here. This energy level 1, Riemann we start from this. For Baumann we start from this. Yes, ahangaha iyo ushaka kudrawinga, yes, Riemann series umurongo wa mbere uca zino ntuza energy level ya mbere ni ya kabiri. Noneho akarongo ka mbere uyu nguyu turamwita Riemann, aka kabiri uyu nguyu turamwita Baumann nkuko kubibona ahangaha. Paschen akurikira ahangaha na bracket. Ahangaha Riemann umurongo wa mbere uva kuri n ubwo n initial nahangaha twatangiriye, ubwo ni kuri kabiri. Kuri Riemann ubwo n initial umurongo wa mbere ni kabiri, final ni rimwe. Ubwo twajya kuri Baumann n initial ubwo yatangira kuri gatatu, n final ni kuri kabiri. Ubwo nkahangaha kubwiye ngo umurongo nkahangaha ukubibona umurongo wa mbere wa Riemann n initial araba ari kabiri, final na hano ari kujya soreza. Umurongo wa kabiri ni uyu nguyu, n initial yaba gatatu, n final yaba rimwe. Umurongo wa mbere, wa kabiri, wa gatatu, n initial yaba kane, final ni rimwe. Urabona hano kuri final we ari kujya soreza ahangaha kuri rimwe. Kuri Baumann nawe kubwiye ngo umurongo wa mbere first line, ubwo n initial tuvuge niba ari uyu wa mbere, n initial iraba kane, final iraba kangahe? Iraba yes, sorry for that. Nitujya hano kuno ntuza kuri Riemann, sorry, ndakeka hano kuri Riemann uko bishushanyije, yes, uko bishushanyije. Ubwo Baumann turahera kwa kano gasanduku ka kangahe ka kabiri gutya. Umurongo wa kabiri mbega ahangaho aho ntago ari byo, ni ukuvuga ngo urifashisha iyi ngiyi ni uragenderaho nk'urugero. Hano uyu murongo wenda umurongo wa kabiri kuri Riemann ahangaha turaza tuwudoringe gutya. Umurongo wa gatatu ubwo wajya kuri ntuza energy level ya kangahe, tubwe energy level ya kangahe ya kane, yes, ukaza ahangaha gutya. Ubwo umurongo wa gatatu wa Riemann n initial yaba ari kane, n final yaba ari rimwe. Nuko kuri Baumann watangira kwa kano gasanduku ka kabiri, umurongo uyu wa mbere utangira ahangaha, uwa kabiri ubwo urakurikiraho gutyo, ubwo hano bambwiye ngo umurongo wa kabiri wari wo kuri baromani kuri n initial, ubwo ndareba aho yatangiriye n initial, ndaza ahangaha ubwo ni 4. Yes, ubwo n final ubwo kuri baromani ubwo ni n final birabaho yasoreje ni 2. ubwo hano no fresh iri kugisorezwa niho haba hari kuri final, noneho ari gutangira ni kuri initial. nuko nguko ano maseries bayubaka. Then ahangaha ino n initial na n final uzayikenera ryari igihe bazavuga ngo ushaka wavelength. Wavelength hari formula dufite yaho gushaka wavelength ingana na 1 over wavelength is plus r h, iyi ni constant barayiguha. Yes, ubwo ni formula 1 over n2 square, ubwo n square ubwo ni n final plus 1 over n n'ubundi ingi iba square, buri n zose ziba square initial, ingi ni initial iyo watangiriyeho. ubundi hano ni igihe bari kukubaza ngo shaka wavelength. Yes, yes, we will use it in the next slide, this formula how to find wavelength wifashishije ino formula. iyi ngiyi constant barayiguhereza, ubundi ugasigara ukumenya ngo n final ni n initial ni iyihe. niba baguhaye rimani bavuga wenda ni umurongo wa kabiri wa rimani cyangwa umurongo wa mbere wa rimani, ushoboye kuza ukavuga ngo n initial ya rimani ni kangahe, ubwo ni initial ni hano ni kuri ni kane. Yes, biraza kuba ahangaha kuri 2, final na ahangaha kuri 1. wenda bashobora ngo rimani umurongo wa mbere, ubwo n initial yaba 3 kuko ni uno umurongo wa mbere utangirira, aho urarangira ni kuri 2, ubwo final ni 2. This is how this straight line explained. This is the formula how to find wavelength. iyi ni formula wakwifashisha ushaka wavelength bayikubajije. imaze kubona wavelength biba byoroshye ko washaka iki frequency. Frequency symbol ni ngutya bayisymbolize like this, equal to speed of light. Speed of light is equal to 3 times 8 meter per second over wavelength. This is the wavelength. This wavelength, iyi wavelength niyo wabonye ahangaho ugikarikiye, wahinze ukaza kwifashisha ahangaha. iyo umaze kwifashisha ahangaha uguhita ubona frequency. frequency uyibonye ushobora guhita ushaka energy. energy ingana na Planck constant times iyi frequency. frequency wamaze kuyibona wayikarikira ahangaha, urahita uzuyisimbuza ahangaha ukuye Planck constant. Planck constant ngiyi constant yawe 6.63 10 minus 44. This is, remember, the unit of energy is equal to joule per mole. The unit of frequency is equal second minus or hertz. Then remember here, if you have 1 nanometer, hari baguhereza noneho frequency iri muri nanometer uhindura muri metero. nanometer imwe birangana na metero imwe na 110 power minus 9. ahangaha biba bisa ngo umuhanzi ugiye bayiguhaye muri nanometer, wenda baguhaye nka 4 nanometer ni nk'urugero example, ibikwiye kungana na metero zingahe. ubwo urafata 4 ukubeho 10 power minus 9 equal meter, nurangiza uyifashishe uri gushaka iki, uri gushaka frequency muri meter. Yes, meter. Yes. Also, this is the formula. Iyi formula is in speed of light ingana na 3. Yes, 10 power 8, you know. Angi ni wavelength, ingi ni frequency. Anga ushoboye gushaka, bashobora kubaza ntuza hano speed of light biri constant, ahubwo anga ushoboye gushaka wavelength. Hani wavelength iyi formula nayo irifashishwa ya wavelength igihe hatarimo n ya mbere. iyo utari kumva n initial na n final, ye ntazi ukumva mu kibazo wifashisha ino formula. ushobora gufata speed of light over iyi ngiyi ni frequency. frequency wayishaka wabonye uko twayishaka, warangiza iyi ngiyi speed of light bihari constant ukifashisha iyi ngiyi bihari constant. Then iyi ngiyi ni energy, ni Planck constant times frequency twayibonye. This is how to find this energy by using this formula. Yes, izi ni formula ukwiye kumastering, ukwiye kumenya mbere yuko wakora ibibazo. Ahangaha bari kuvuga ngo wavelength yongereye frequency ahangaha iragabanuka. Hano frequency yagabanutse, wavelength yagabanutse, hano frequency iriyongera. This is This is bavuze kangahe ingana na nanometer zingahe? Yes, ingana na metero gutya. Ibihanga none one more ingana these atoms is atom. Yes. Then this is the question, this is the exercises. Is no exercise, these exercises will use it, for example, find in a given transition of an electron from N5 to N2. This N5, here N5 it is from, this is N5, it is initial, then N2, yes, N2 it is a final, it is a final. Here if we are going to ask energy, what calculate energy? Energy is equal to Planck constant times frequency, when frequency is equal, yes, speed of light over wavelength. Then what about how to calculate wavelength? Wavelength will use this formula, 1 over wavelength is equal to, yes, this constant over, is 1 over n square, n final square plus 1 over n square n initial. Ahangaha uramanza ushake wavelength kugira ngo kugira ubone frequency na energy, urahera kuri wavelength. Wavelength urifashisha ino formule n initial wayibonye kari 5, uraza ugasimbuza ahangaha ugahashyira 5 ugire square, wongera ufate n final ariyo 2 ugasimbuza ahangaha ukagire square, nonaheza ukarikira bisanzwe. Iyi ngiyi nayo irebe turayifite constant yayo. Then numara kubona iyi wavelength uraza wifashishe ushake frequency wifashisha ino wavelength wabonye ahangaha. Speed of light turayifite ahangaha irazwi, yes, ni 3 10, yes, power 8 meter per, yes, meter per second, you know, meter per second. Numara kubona wavelength, frequency, urahita uza gushaka energy. Yes, this is also this, find the wavelength, bakwaza wavelength, frequency, yes, energy for of the third line of Riemann. Ubwanga bari kukubaza ni umuntu wa kangahe? Wa 3 wa Riemann. Riemann iyi n ya mbere dufite umuntu wa 2, hano dufite energy level ya kangahe? Ya 3. Here we are going to see, yes, ahangaha ubwo umurongo wa mbere n'uyu nguyu kuri Riemann n'uyu, ubwo umurongo wa 2 n'uyu nguyu, ubwo umurongo wa 3, yes, turawudrawinga. Umurongo wa 3 n'uyu nguyu bari kukubaza. Umurongo wa 3 rero wa Riemann series, iyi ni ntuza ya Riemann series. Uraza uvuge ati n initial ni n initial, n final ni n1, aho biri gusoreza ni kuri n final. Muri make n final irangana kangahe? Irangana na 1. Noneho umurongo wa 3 kare bambwiye ubwo n initial byatangiye ni kuri n ya 2, n ya 3, n ya 3 ni iraba n final. Ubwo muri make n final yo ku murongo, yes, hariya urayifashisha ari kangahe? Sorry ni initial n, aho ino electron yatangire kuri n initial, n initial is it free. Then ubundi ukaza gusimbuza mwino formula gushaka wavelength na frequency na energy. This is the exercises in your exercise book. Try to do it and we submit. Yes, okay, let us continue. This is the end. Thank you for your kind attention and God bless you. Dear brothers, ladies and gentlemen, this is the PowerPoint presentation. This is how to use ICT in education. I would like to call every, yes, learner to be attentive when you are listening these videos, because at the end of these videos I'm going to ask you a question. It is like a pop quiz. For sure,